you related it with the power dissipation.
Correct. So interconnects required. If you see that these are the subsystems, right? And we are putting this subsystem. These are, I am showing it here subsystem. If it is just subsystem point of view, if you keep this subsystem on the motherboard separate, each subsystem, right? Consider that each subsystem we actually taped out and that we got a chip and then we actually put it there on the motherboard. So all these things, right? If you see that in motherboard, the connectivity is required for all the way. Then again here, if this NOC is not there, if this NOC is there, again we have to put the chip for the NOC. Then NOC connectivity will be there, right? Means there are how many subsystems are there? If you consider that one subsystem as one chip, how many subsystems are those many interconnects are required to connect it to the memory controller as well as to the CPU? If NOC is there, again the separate NOC at the center of the motherboard, we have to keep the NOC. Okay. So if you keep everything into the same SoC, right, it's very close together that all the routing and all the things will be actually placed. It depends upon their the routing, place and route analysis.
So doesn't it increase the system capacitance overall by keeping them closer?
No, actually that will be taken care by using the signal integrity check rates. So overall capacitance increased, right? Then overall performance also will go down. Correct? Parasitic capacitance will increase.
We are introducing the entire network on chip.
Correct.
So network on chip means interconnects are very closely kept.
Yeah.
And not only in between the systems or at the center of the system also.
Yeah, that's what actually while putting together all the subsystems, right? There will be ground levels and everything, enough grounds will be provided. Then in the way that the parasitic capacitance should not be formed and it should not disturb to the signal passing from the one system to other system or the memory controller.
Why am I asking this question? Because in the distributed kind of a thing, you do not have a network on chip kind of a thing.
Correct.
So the interconnects are widely
and distributed.
So the entire capacitance of the network on chip is quite reduced.
Correct.
And it is not hampering the performance circuit.
Correct.
Now what you are doing now, you are putting the network on chip on the same chip.
Correct.
So for that purpose, we need to see the area constant also.
Correct. Yes,
so because of that area, you are keeping the interconnects very close to each other. Those are related to the network on chip.
Correct.
That's why I was asking capacitance will
increase. That will be taken care into the technology. That new technology is actually 3 nanometer, 5 nanometer, and signal integrity checks and other things, right? And for the driving the signals from the one subsystem or from the NOC, right? Already the enough ground will be provided not to form the parasitic capacitance. That will be taken care in the place and route time. So once definition stage is over, then the functional specification will start. To achieve that functions, what are the things required? Means, what are the IPs required? What are the generic IPs are required? What are the application specific IPs are required? Those, all the things will be identified. And once those things are identified, then the design will start. For that design, each IP or each application specific IP or generic IP, that the architecture definition stage will be started. Once architecture definition stage will start, then microarchitecture definition, then putting into the RTL verification, everything will start. So what are the boxes that I showed it here, right? That box is having a lot of things involved into it. For example, the IP development. IP development is lot of the things will come to the picture there. The architectural definition for that IP, microarchitecture, implementation, backend process, everything will be closed for each IP, and then only actually comes to the SoC level. So once we identify what are the IPs are required, then first definition is done, then software and hardware partition will be done, then SoC hardware level architecture and design phase will start after the finalizing which are the IPs are required and all the things, and then SoC hardware level architecture design and everything will start.